So since you are amazing at being able to solve a system of equations by elimination, we're going to get you to practice how to do a system of 3 equations with 3 variables by elimination. So when it comes to systems with 3 equations and 3 variables, we are looking at how to solve for x, y, and z. So we're in 3D instead of 2-dimensional space. So when it comes to the graphs, this is what they look like. So instead of having 3 lines, we have 3 planes. And where do they all intersect and share an x, y, and z value? So just looking at the graphs here, the plane in red and blue and green. So this is an example of what it would look like when you have one solution. So this graph right here is an example, and our solution would be right here smack in the middle where the 3 lines cross. And this is a case when we have one solution. Now there are also cases of what happens when we have infinitely many solutions. In 2-dimensional space, that's where the 2 lines overlap each other. In this case, it would be where the 3 planes cross one another. So we look at the first graphical representation here. This is an example of where the 3 planes intersect each other, and they all share an answer. And that spot is right here. Let me change the color so you can see it a little bit better. This is where we have all our answers. All those points on that line where the 3 planes cross would be all our infinite solutions. Or it can be another case where the planes are all the same plane, so they're all on top of each other, just like when we have 2 lines in 2D space that overlap each other. In this case, we can have 3 planes that are all exactly the same plane. So we also have infinitely many solutions, and that's 2 cases of that occurring. And then the last case would be when we have no solution. In this case, where we have, in 2-dimensional space, we would have 2 parallel lines. In 3D space, this is where we have 3 parallel planes. They don't intersect anywhere, and they don't share any one point x, y, and z. Our other case would be this one right here, where the planes do cross, but only 2 planes cross each other at once. There's nowhere where all 3 planes cross one another and have an x, y, z point that they all share. So these are our 3 cases when it comes to systems of equations, but with 3 equations. All right, so let's go ahead and look at how we're going to actually solve these. So here's a basic plan, and it gets a little convoluted because there's a lot of different things we can do, and there's more than one way to do it. But I'm going to try to simplify it as best I can, just so you won't get confused. So the general plan is, 1, you're going to pair up your equations and eliminate 1 variable. So we're going to make 2 pairs of 2 equations from the 3 equations. So I find it easier just to pair the first equation with the second one and make 1 new system and then pair, and then from that one eliminate 1 variable. It doesn't matter if it's x, y, or z. So pair 1 and 2, multiply them by something if needed, eliminate 1 variable, and get us a linear equation with just 2 variables because you're eliminating 1. Once you have that, you're going to select a different pair. I usually pick the second equation and the third equation just to keep it general. And I'm going to eliminate that exact same variable. If you need to multiply one of the equations by a constant, go ahead and do that. Once that's taken care of, you have 2 new equations, and I usually just call them A and B, just so I know what I'm referring to. You're going to take A and B that are only going to have 2 of the 3 variables, the same 2 because you eliminated the same one earlier in steps 1 and 2. And then you're going to just solve that system of equation because it's going to have 2 equations like we learned how to solve a regular system with 2, and that's step 3. And once you solve for 1 variable, you plug it back into either equation A or equation B here. So you're going to solve a 2-variable system using any method, right? So you're going to solve for x, let's say for x, whatever that is, and then you're going to plug it in and figure out the y. Or you're going to solve for y and figure out x, or you're going to solve for y and figure out z, and so on. And many combinations that this can work out in. So once you have your x and your y, or your y and your z, or your x and your z, you're going to go back to the original equations and figure out the last remaining variable. So I'm going to go ahead and go over how to do this. It'll make more sense when you see it. But note, just one quick thing. How do we get the no solutions and infinite solutions? The same way we did before. Once you get a false statement, you have no solution. Anytime you get a true statement, you're going to have infinitely many solutions. So let's go ahead and turn around our paper and start the practice. Okay, so we have our 3 equations right here. first one's going to be 1, 2, and 3 in that order. So I'm going to start off with equations 1 and 2. So let me actually put the pen down. All right, here we go. I'm going to take equations 1 and 2, and I'm just going to rewrite them. As I see them right now, they're not going to cancel, so I'm just going to take the second one and multiply it by -1, so the 4 and the 4. The second 4 becomes negative, and they cancel. So I'm going to eliminate the x's because they seem like they're the most convenient. Looking at the y's, I'd have to do more multiplication, so I'm just going to make it easier on myself, and I see that the x's seem to be the ones that cancel the easiest here. All right, so there's the first equation, and the second equation, I'm going to multiply it by a negative. So that's -6y and positive 5z equals positive 12. So I paired up my first two equations, and I'm going to pair up the second and the third equation. These are already ready to go in terms of canceling, so I don't have to modify these two or transform them in any way. So I'm just going to keep writing this. And then we have -4x minus 2y plus 3z equals 4. So I paired up first two equations, paired up the second and third equation. I set them up to be ready to eliminate. Remember, I want to eliminate the same variable on both of these. These cancel. The x's on both of them. So I have -5y plus 4z equal to 1. On this side I have 4y minus 2z equal to -8. All right, so now I have two new equations that just have two variables. I know how to solve a system with two equations on two variables. These are the ones I said to call A and B. So I'm just going to quickly label A and B because if I refer back to them, you'll know what I'm talking about. So I'm going to put these together as a system. Looking at them, nothing is going to cancel directly if I look at them the way they are. So I am going to modify these two equations by multiplying them by something. So I'm just going to go ahead, again, if you want to multiply it first, I'm just going to write them out just so they can look a little neater. And I'm going to then transform them. But if you want to transform them before writing them down, that's perfectly fine. All right, so here we have our equations. I'm going to see that it's easier for me to multiply the second equation by 2. So I'm going to multiply this one by 2. So the z becomes a 4, and they can eliminate. So I'm going to go ahead and rewrite this. 5y negative. So I'm going to multiply by 2 plus 4z equals 1. We're going to get 8y minus 4z equals 2 negative 16. And I'm going to solve this system like I've solved many other ones before. These cancel. I get 3y equals negative 15. And you divide by 3, and you get y equal to negative 5. So we solved for our first variable. Now we're going to finish solving and plug it back into either equation A or equation B. So just like a regular system, you can ignore the part in purple. If we're just looking at the part in green, this is just a system with two variables. I'm going to go back and I'll plug it into the first equation. So I'm going to clear this out because I ran out of room, but you should have it on your paper. All right, and scroll up just to make sure I have room. Actually, that's fine. So now I'm going to take my y equals to -5, and I'm going to plug it in. I'll plug it in back to the first equation, which I'm going to call A, or which I called A. So I'm going to take that y equals to -5, and I'm going to plug it back into A. So it's going to be -5 times -5 plus 4z equals 1. And that's 25 plus 4z equal to 1. Subtract 25. So 4z equals -24. Divide by 4. Z equals -6. So we have our second variable. And now we're on the last step, which is now that we have z and y, we're going to go back to the original equations and plug in y and z and solve for x. It doesn't matter if you use equation 1, 2, or 3. Pick whichever one you want. I'll just pick the first one just for simplicity. So I'm just going to pick equation 1 and plug in those y and the z. So we're going to get 4x plus y, which is negative, so I'm going to use parentheses, minus negative 6, use parentheses again, equals negative 11. And now we're going to simplify. 4x minus 5 plus 6 equals negative 11. 4x plus 1 equals negative 11. Subtract 11, subtract 1 with 11, and that's going to give us negative 12. And divide by 4, we're going to get negative 3 for x. So we solved our system. The solution is x is negative 3, y is negative 5, and z is negative 6. So our xyz point is negative 3, negative 5, negative 6. So that's just a general way to solve this. Let's go ahead and try the second one. So let's scroll down. Here we go. All right, so start off again. We're going to decide which variable are we going to eliminate from our equation. So we're going to pair up 1 and 2, 2 and 3. And I'm going to decide what am I going to eliminate here. So I'm going to take 1 and 2, pair those up. So if I'm looking at them, it's easier if I get rid of the x term because I can just multiply the bottom one by 3. Now we can eliminate the y's, but that would require me to multiply the top by 5 and the bottom by negative 4, which requires me to do a little bit more work. It still works, but I'm just going to be efficient. Take the first equation and keep it. I'm going to take the second equation and multiply it by 3. But I want to make sure it's negative 3 because the signs are the same. So I want a positive 6x. That means I need to multiply this by negative 3. So if I multiply by negative 3, I get the following. So I get 6x minus 15y plus 6z equals negative 33. I'm going to pair up equations 2 and 3. So I'm going to decide what I'm going to multiply by. In this case, I am going to multiply the second equation because I have to eliminate the same variable. I decided x as well. So I'm going to multiply the bottom equation by 2. So this one's going to get multiplied by 2, so it can cancel with this negative 2 here. So I'm going to keep my first equation. And I'm going to multiply the second one by 2. So we get 2x plus 8y minus 6z equals 44. Now I'm going to go ahead and eliminate the x on both of them. It has to be the same variable. So eliminate, eliminate, and get my new system. So I'm going to get 11y negative plus 11z equals negative 55. On the other side, I get 13y minus 8z equals 55. Now, something I just want to point out, the first equation, these are all multiples of 11. So I can actually just divide everything by 11 and make it a little easier to work with. So I'm just going to simplify this equation just to make it easier for me to work with for later reference. So I'm going to get this equation. So this is going to be my A equation, and this will be my B equation. So I'm going to solve this system now, the A and B combo. I have 2 variables I can solve with 2 equations. So I am going to see that with equation A and equation B, I can probably multiply the first one here. If I want to eliminate the y's, I can multiply by 13. If I want to eliminate the z's, I can multiply by 8. So I am going to go with multiplying the equation by 8 just because it's a smaller number. So I'm going to take the first equation and I'm going to multiply it by 8 when I rewrite it. Let's change the color. Let's try purple. So I'm going to multiply this by 8. So I'm going to go negative 8y plus 8z equals negative 40. And I'm going to take my B equation. It's 13y minus 8z equals 55. I'm going to solve the system like any system I would solve. And I got 5y. These eliminate, equals 15. So that means z is equal to, divide by 5, 3. Not z. That would be a bad mistake. Y equals 3. All right, so we have our first variable. Now we're going to go back and plug in 3 into either equation A or equation A here or B here. It doesn't matter which one. I'm going to go with A because it seems a lot easier to plug into A than it is to plug into B. So I'm going to clear this out and just plug in. Actually, I think I can squeeze it in here on the side. You can probably work below or wherever you can fit it. So it's negative y, so negative 3 plus z. So I'm using equation A, the original one, right here, equals negative 5. If I add 3 to both sides, I'm going to get negative 2. So I have my z value. Now that I have y and z, I'm going to take y and z and go back to the original 3 equations and decide, am I going to plug it into the first one, the second one, or the third one. Just by looking at all of this, it seems a lot easier to plug it into the first one because the x is already by itself. So I'm going to go ahead and do that. I'm going to clear this out. All right, so we're going to do x plus 4 times y, which is 3, minus 3 times negative 2 equals 22. X plus 12 plus 6 equals 22. X plus 18 equals 22, which means x is equal to 4. So my final answer is 4 for x, 3 for y, negative 2 for z. And that's pretty much how it works. There are more videos if you want to see, or there's just actual written examples out on Canvas. So take a look at those if you need more practice before you actually do the practice assignment. So go ahead and good luck.